What if the lines are provided in this manner? Let's try to find the half turn of the given point x together with the point P, which is the intersection of both lines. By the way, just by the examination of two lines, we know that these two lines passes to 1 and 0. Automatically, that's our point P, which is at 1 and 0. Together with our point x being 5 and negative 1, we can now determine the half turn of your point x along the lines alpha and beta by the formula negative x plus 2p. Okay? So basically, simply try to substitute here negative of your x, 5, negative 1, plus twice your p, 1 and 0. Again, it's a common point for both lines, so it's already there. You'll have negative, let's try to multiply the scalar quantity. Negative 5 plus positive and positive 1 plus 2 and 0. This means you have here negative 3 and 1 as the half turn of your 5 and negative 1. Our 5 and negative 1 can be found here. 1, 2, 3, 4, 5. Negative 1, so somewhere here. This 5 and negative 1. So its half turn is at negative 3, 1, 2, 3, and then 1 here. This should be the half turn of that. But half turn in which perspective? That is why, even if we have this result, allow me to graph the two lines in order for us to really look at the picture of negative 3 and 1 being a half turn. Since our lines are expressed in these notations, L is equal to your point B plus your V. Okay, so let's try to come up with the form AX plus BY plus C is equal to 0 to find the X and Y intercepts. Okay, for our graph. So let's start with our alpha identified as 1, 0 plus your direction vector 3 and 4. Take note, this is just a direction vector. To identify the A and B, it's actually part of your normal vector A and B. So if this is your direction vector for alpha being 3 and 4, its normal vector will use negative v sub 2 and v sub 1. Please try to review this process. Your v sub 1 is a 3, so you have here 3 and the negative of 4. This is your normal vector for your alpha. This means this is our A and that is our B. So for AX plus BY, okay, plus BY plus C is equal to 0, we can have here negative 4X plus 3Y plus C is equal to 0. To solve for C, please try to review the first playlist on this series on analytical approaches to modern geometry because we're also talking about this one here. To solve for C, let's use here 1, sorry for that, let me change the color, our point 1 and substitute that here to solve for our C. That means you have negative 4 times 1 for your X plus 3 times 0 plus C is equal to 0, negative 4 plus 0 plus C equal to 0, negative 4 plus C is equal to 0, so C is positive 4. Hence, the actual form of this in terms of AX plus BY plus C is, we have here at the bottom, negative 4x plus 3y plus 4 is equal to 0. If you don't like negative leading coefficient, you'll have 4x minus 3y minus 4 is equal to 0. This is for our alpha. Okay? Let's talk about it later, as we also need to come up with our B. If you don't need this processes, you may skip because the first and foremost goal of that is already identified here. Okay? But I'm just trying to illustrate this so that we could really appreciate the picture of our graph. So you have the its direction vector is negative 4 and 3, which is similar to that, right? Because that is actually the relationship between the normal vector and the direction vector of a line. They must be orthonormal. And either way, if this is our vector v for our beta, which corresponds to negative 4 and 3, the normal vector is actually identified again as negative v sub 2 and v sub 1. You will have here negative 3 and negative 4. This corresponds for your A. This corresponds for your B. So for ax plus by plus c equal to 0, we'll have here the form negative 3x minus 4y plus c is equal to 0. Again, using this here to solve for our c, so we can have negative 3 times 1 minus 4 times 0 plus c is equal to 0. Negative 3 minus 0 plus c is equal to 0. Negative 3 plus c is 0. So c is actually positive 3. So for our final form, in ax plus by plus c, you have negative 3x minus 4y plus 3 is equal to 0. Again, if you don't like negative leading coefficient, 3x plus 4y minus 3 is equal to 0. These are the representation of the two lines in terms of ax plus by plus c. Allow me to add additional page here, okay, so that we can actually graph, look for the intercepts of both. 4x minus 3y minus 4. So you have here 4x minus 3y minus 4 is equal to 0. That's for our alpha. And for our beta, you have here 3x plus 4y minus 3. Sorry. 3x minus 4y, plus, if I'm correct, plus 4y minus 3 is equal to 0. So for the alpha, let y be equal to 0 for the x-intercept. So you have here 4x minus 0 minus 4 is equal to 0. 4x is 4. X is equal to 1. So you have here 1 and 0. For its y-intercept, so you have 0 minus 3y minus 4 is equal to 0. Minus 3y is 4. Y is negative 4 thirds. You have 0 and negative 4 thirds. That's for our alpha. For our beta, let y be equal to 0. So you will have your 3x plus 0 minus 3 is equal to 0. 3x is 3. So x is 1. So 1 and 0 as well. You can see we have here common points for two of them. And that corresponds again to their point of intersection here, our P that we used earlier. So everything is now being cleared. Let's continue. Let x be equal to 0. So you have here 0 plus 4y minus 3 is equal to 0. 4y is 3. So y is 3/4. Its y-intercept is 0 and 3/4. All of these points, let's try to plot them on our Cartesian plane. Let's have alpha. We have 1, 0. Okay. 1, 0. And 0 and negative 4 thirds. So 0 and negative 4 thirds. That's negative 1 and 1/3. So here. So the line alpha, okay, would connect these two. And assuming again that it's accurate, that's our alpha. Okay, sorry. This is our alpha. For our beta, it will still pass at 1. Sorry for that. Okay. I was jumping on a different page. You have 1 and 0 and 0 and 3/4. So again, so it passes here. The same thing passes there. And we have 3/4 or 0.5 for something here. Almost 1. Connecting them. Sorry for that. Let me redo it. Because probably, yeah. Let's just assume that it should not actually pass through 1, but it's almost there. The problem now is it doesn't look, they don't look perpendicular, but nevertheless, let's just assume that it's final. And let's have the last one. Okay. This will be our beta. Again, let's just simply assume that my graph is accurate. So your beta. And as you can see, when we draw a line passing through the point P and to our point X, it is the verification that our half turn earlier is correct. Is that we can see that all those 3 points will coincide. The point X, the point P, sorry for that again, the point X, the point P, and our half turn. So we can see that they lie on one line, hence this really proves that we have 180 turn here, so half turn. So this is correct. Negative 3 and 1 is our half turn for our identified X here along these lines. So pardon for a very long process of graphing because I would like to illustrate that really. But if the question is just half turn, you may end up here and that's really okay. Thank you very much for watching.